So excited, so many people are interested in gRPC, and to hear about my journey of using gRPC for the past 5, maybe 6 years. So a quick question, who here uses gRPC in production? Raise your hands. Nice, so we have quite a few people who are not using gRPC, and this talk will be excellent for you, and obviously for those who already do. So a quick introduction. My name is Konstantin. I'm the chief architect at Torq, a cybersecurity, no-code automation startup. I love working at cybersecurity startups, and for the past 12, 15 years, I've been a member of several of them. I have a guilty pleasure. I love optimizing CI build times. Who here loves optimizing CI build times? Raise your hand. Yeah, it's a rabbit hole you go down into, and you can spend days on it, shaving those seconds. Just so you know what Torq is about and what basically set the stage for using gRPC, few words about what we do and our tech stack. So think of us as Zapier for security automation, for security analysts. People who have to build automation, but they don't like writing code. They like graphical user interface, building automations in the UI. We are a team of about 50 engineers now. We do microservices. We use Go. We use gRPC for everything, which is a bit unusual because in the front-end world, front-end engineers don't really like using gRPC. And it's quite not ordinary for them to do it. We use Postgres, Redis, and all that stuff. We run millions of automations every day, and we run on top of GCP. So why did we pick gRPC? The team who started building this company was originally working together at another company. In that company, we were like, yeah, REST API, Swagger, Open API files, and stuff. But we didn't like the code generation tools that were available at the time for REST. Specifically, in the Go ecosystem, they weren't that great. So what ended up happening is that our engineers didn't like the generated code, and they would go and implement clients and servers themselves, which meant you had like 5 different implementations for handlers and for clients. And it was a pain to maintain it. So our primary goal with gRPC was, this looks like a framework that is backed by a large company, a large ecosystem, open source community. We believe that the code generation tools available for this tool will be great, and this will reduce the workload that our engineers have to deal with, and not have to think too much about how to implement this layer for APIs, both on the server and on the client side. gRPC is also a binary protocol. It's supposed to be faster because it transmits less data over the wire. And another really cool feature about it is that it's backward compatible by design. If you try hard enough, you can break it, but in general, for most use cases, it works great, and we rely heavily on it. So what is gRPC for those who are new to it? gRPC stands for Google Remote Procedure Call. It's a high-performance RPC framework. It's language agnostic, which means you have support to generate clients and servers almost for every programming language. Sure, they are all kind of modeled after Java style of interface, and they are not exactly idiomatic Go or TypeScript, but they do an excellent job. It's backed by protocol buffers, which is a binary protocol for encoding structures. It has an IDL that lets you define structs with some primitive types, and it's also a CNCF project. So, as a developer, working with gRPC is quite simple. You define your services, messages, which are like input and output for different methods that your service implements. You use some CLI tool to generate from this proto-language the clients and the servers. You then implement your server's logic, and you use the client to communicate with the server. Typically, this is how it works. One cool thing about gRPC is that it uses HTTP2 for communication, which means that it's able to multiplex multiple streams, multiple requests over a single HTTP2 connection. And this is really cool for reducing latency and be way more efficient for data-intensive or high request rate applications. However, the problem with this HTTP2 is that it has some challenges on Kubernetes with load balancing, which we will address in a bit. So we said binary protocol over HTTP for performance, backward compatibility by design, which was a really important aspect for our product, a strongly typed API contract language. Basically, all APIs are defined in the same way across different microservices. You have excellent client and server code generation tools with wide support for almost all programming languages you care about. Nice Go support, TypeScript support, and it has built-in extensibility by design, which is really cool for annotating your proto messages with some extra attributes for achieving stuff like role-based access control, which I will show in a bit. So how do we make APIs work at Torq? We try to stick to these rules. We want to lint everything that we can, everything that we can lint. If there is a tool for it, we will add it to our CI pipeline. We want to maintain the same standards for everything and make sure all our services look more or less the same, to have our engineers focus on the business logic and not on thinking too much about naming or stuff like that. Everything should be a standard. Backward compatibility is also enforced using a linter, which checks that you didn't delete a message or you didn't do any backward compatible breaking changes. This means removing an RPC method, changing a type of a field, deleting fields is generally discouraged. One thing we learned is that when you start defining APIs, you really want to share messages between different, to share common messages between different implementations and different services. For example, you may have a user object that you want to reuse across different services. And in our experience, it didn't work that well. And it creates like tight coupling and spaghetti between different APIs, which is why we generally try to duplicate messages or same messages and keep them under the service domain that they belong to. There is also a really handy tool for those who are just starting out and want to adapt gRPC. It's called the Google API Design Proposal. It's a website with tons of information about the way they design APIs at Google. Granted, you are not Google and probably will never be, but there are some good learning and good information there that will help you make the right choices when designing APIs. We certainly read everything, but we adapted some certain parts of it which work in our case. And I highly recommend looking there because it's a really nice guide of how you should think about API design and implementation in your company. In order to streamline the development experience for our engineers, we created a Docker image that contained the plugins and the shared configuration among that we use for generating our code and our clients and servers. Excuse me. And our developers use it on their machine. This means that the developers don't have to install the proto-compiler or any of the plugins there. So how should you organize protos in your project? At Torq, we like multi-repos, and this is what works well for us. We keep the APIs in the service repository in its own directory. Since we are a primary Go company, the generated clients and the servers are also committed to the service GitHub repository, which means if another service that would like to communicate with me, they can consume the clients using the Go module manager. So they do just go get, and they can use my clients. Here you can see a typical directory structure for our microservice. You have an API directory which hosts all the proto files. Each service will have a directory with a version that signifies the current API version. Each of those will have the proto files inside. In case some repos should be used in a front-end project, we use the GitHub artifact package registry to host those. So what benefits do we get from gRPC? If I had to summarize it with just one sentence, it's unified API standards. Developers can move between different teams, and they're already familiar with the standards that we have. There is way less code to review because no one is implementing their own clients or servers, because we trust the code generated by the tools. We have built a lot of middleware, which is kind of the way it works in REST API as well, that does some really cool things and provides a framework for our engineers. So we use a middleware for authentication, authorization. We use a bunch of middleware for observability, which connects really well into gRPC. In addition, there is a very big ecosystem of middleware that open source engineers like yourselves build for gRPC, and it's super convenient to use. Usually, when you need something, someone has already built a middleware or some tool for it. Another really cool thing that we like is the extensions. So above, you can see a typical vibe coder gRPC service. The standard syntax for gRPC allows you to define a method, which is vibe code, a request, a response, so basically input and output for this RPC. One cool thing about gRPC is that you can extend it with these options attribute. For example, here I demonstrated the way we do role-based access control in Torq. So each API will have an attribute which defines the scopes that are required to be present on the session objects that when a request reaches the service will be verified. This is a really convenient way that works really well for us for managing everything related to APIs in the same place. For example, other extensions that we have are flag-based feature management embedded into gRPC. For example, this means that if I don't have a feature flag for vibe coding, I will not be able to code this RPC, and this is enforced in our middleware, and it's super handy. So what are the lessons that we learned and for the past 5 years? And I think most of the friction when using gRPC is in the beginning. You have to decide what directory structure you're going to use. How are you going to do dependency management? The way gRPC and Protos are used in Google is via a monorepo. And in our case, since we wanted to use multiple repos, we have to figure out dependency management by ourselves. Sure, there is a great Proto compiler CLI tool which is available for all, but the developer experience for it is not great. You usually end up building your own makefile that runs it, or you have to build a Docker image, which is 10 gigabytes of binaries that every engineer has to pull to their machine. With frontend, it's also not super convenient because, let's face it, front-end engineers like REST APIs. They like using the network tab in Chrome to debug the requests, and they are not really happy about binary formats. Another thing that we also faced is that at some point you will want to provide some APIs for your customers. Sure, you may like new technologies, but your customers are unlikely to be happy with some gRPC APIs that have to use, and you will end up getting some REST API in your code base anyway. Another challenge is with Kubernetes load balancing. So Kubernetes isn't great with HTTP2 load balancing out of the box. HTTP2 uses long-lived connections, and since there is no disconnection, it will not be able to spread the load between different pods once the connection is established. And you will have to either implement some load balancing logic in your gRPC clients using headless services in Kubernetes, or use some kind of a service mesh or a proxy which does this for you. Specifically at Torq, we use Linkerd, so we get this out of the box, and it works really well for us. Message reusing. As developers, we don't like writing the same code twice. We live by the dry principles. Unfortunately, with gRPC, it's not that great. You should think of your gRPC files inside a service domain, which means that if I have a user service and an order service, I will not be reusing the user structure in the order service. I will prefer to duplicate it. Dependency management with gRPC is not that great, and from 5 years of experience, I highly recommend just duplicating everything instead of reusing the same messages. Within a single microservice, it is fine to use, and it's encouraged to use the same messages, but not across boundaries of the service. gRPC Web. I mentioned it a bunch of times, and it's really challenging and it is a constant friction point with front-end engineers. Another issue with it is that it doesn't support caching. So the way it's implemented, it's base64 payload that is transmitted using post requests. This basically breaks down all modern common caching mechanisms that are available in browsers, and CDNs, and stuff. So it's not very great for that. In addition, debugging it requires installing a special browser extension. So if you have a customer complaining about some issue, you can't just ask them to open, well, you can, but it will not be very useful, asking them to open the network tab and send you the HAR file. Usually they will have to install the extension. Of course, there are ways around it, smart ways around it, but generally this is a big pain point. And gRPC requires some kind of a proxy that translates from this base64 gRPC web format into regular gRPC. So it's another middleware you have to install. Some of the open source code may contain some security issues or may create some logic implementation issues on your side because you don't know how it's fully implemented, and it's something that we faced. And again, public APIs are not great with gRPC. There is a plugin called gRPC Gateway. It is much based on Google's annotation for their internal APIs, but it's an open source effort. It allows receiving REST APIs and defining and annotating your gRPC services with some REST annotations. And it does the job quite well. However, your technical writers are unlikely to be familiar with these special annotations for gRPC, and you will have to educate them on using it properly. In retrospect, if we had to do public API again, we would probably use OpenAPI and define the swaggers ourselves, basically have a human define this OpenAPI file to help technical writers and be able to format the file, the OpenAPI file, in the way we want, and not have some strict closed box that is difficult to maintain. Specifically, we have like a post-processing script that runs on the swagger that is generated from gRPC Gateway and have it format and change some things that we don't really like. And it creates some friction and maintainability issues. But things are getting much better thanks to a company that is called Buff. It's actually a bunch of people who worked at Google and learned about the pains of using gRPC without the internal Google tools, and they decided to build a company out of it. Buff is a CLI tool, which is a complete gRPC protobuf ecosystem. It supports remote plugins. It has a single configuration file that defines the way you would like to configure the plugins. It has linting and backward compatibility checks built in, and in fact, we are using it extensively internally. And one thing that it does really great is dependency management. Remember how I said that it's really difficult to reuse proto messages across different services? Well, Buff have a product for that that's called Buff Service Registry. It is solving exactly that point. How do I reuse different messages across services? And it's super handy. Since Buff came to the market about 2 years ago, we basically dropped our custom Docker image that had all the plugins and started using it specifically. Basically, it turned this huge CLI command into a buff generate command and the YAML file that configures it. Another very useful addition that buff guys brought is something called connect-RPC. Basically, to summarize it, it's like a new text-based format, which is based on JSON to allow gRPC communication. You may say, another protocol that no one knows. Well, I guess it is kind of that, but the good thing about their protocol and the tools that they built for it is that it has full backward compatibility, and it supports gRPC web, it supports gRPC, and it supports their own protocol in the same tool and in the same generated code. The biggest addition and the biggest value that comes from it is that they implemented JavaScript libraries from scratch, which keeps the front-end engineers happy now. The generated clients are way easier to work with. They are idiomatic TypeScript and JavaScript. And it's been a huge developer experience improvement. So was it all worth it? Yes, absolutely. I would use gRPC in my next project again for the same reasons we picked it. I like how the generated code, I like how it's standardized, and it takes out second guessing or any discussions from the developers. Standardization is great to keep everyone focused. All the requirements we set for ourselves were met. And with the new tooling by Buff, it makes everything even easier to adapt, and I highly recommend you experiment with it. Thank you very much. Now it's time for questions. Yeah.
Sorry. Hi. Right, yeah, you mentioned front-end hard with gRPC web and stuff. I think Twitch have this technology or a gRPC layer called Torq, which is supposed to translate on the fly instead of if your header's JSON, it returns everything JSON rather than gRPOing it up and sending it. Have you looked into that or considered any of that stuff
Sorry, I didn't hear what technology you were referring to.
Twerp from Twitch, yep.
Yeah, Twerp is cool. I think I actually looked into it, and I don't think like it's still being maintained and developed, which is why we decided to stick with something with bigger community adoption. But it's a great option. I don't think it also supports streaming, but I may be wrong now. Anyone else? Okay, thank you very much, guys. Enjoy the rest of your conference, and feel free to reach out and talk if you have any questions.